Hello in the next episode. In today's video I'm going to repair Nintendo Switch OLED. My customer has tried to install, to solder the mod chip, and he broke his console even more. Now the console doesn't turn on at all. Alright, so this console arrived from Germany. Hello France. This is your console and I'm going to fix your console in today's episode. So let's fix it! Alright, so the console came partially, disassembled. And my customer has told me that one of the resistors near here, so he blew one resistor from here, and he thinks that this caused the problem with the whole console, that it doesn't turn on at all from this point. Yeah, it could be that. This console should turn on automatically when you plug the charger. So we don't need the power button to turn on the console. We need the charger. But I don't know, is it a flux residue or maybe the liquid damage? Looks like it was the liquid damage. You see that? So oxidized. This is the jumper wire. And yes, you see, this is another Nintendo Switch OLED. And it's got resistors, two resistors here, 1 and 2. This one has got only one resistor. So what I'm going to do now, I'm going to disassemble this console, and then we just need to check the motherboard if it's got, any shorts. Because, I don't want to turn this on, causing more problems, yeah? Alright, so the battery is disconnected. We just need to get rid of these tapes. Not all tapes, just one tape. Let's just remove the heatsink. Just need to wipe the thermal paste residue because, I don't like to be all in this paste. It's always better to wipe it. A few more screws. Right, I'm going just to put this on the side. Let's have a look at it. Can you go any closer? This is the closest. Alright. So as we can see, the NAND adapter was installed and it looks quite nice. Here we've got point B, which goes here. Alright, first what I'm going to do, I'm just going to remove the shield from the USB-C port. Let's go under the microscope. Alright, so here we can see, that the... I don't know what's that. Oh, this is just a sticker. So we need to check this fuse first, because I don't want to plug the charge and make, the short somewhere. Maybe someone has done this before. We need to check this first. So first the fuse, and the fuse is good. And now I'm going to put this probe, the black probe, on the ground, which is our charging port. And now, as you can see, this line usually is shorted when it's a problem with the charging port, yeah? This charging port, USB-C port, is a little bit different design than the previous models, like Nintendo Switch. And sometimes you can't see any damage inside of the charging port, but it's completely shorted to ground. The main line, the power line, is shorted to ground. So it's a completely different story than, Nintendo Switch. Alright, so now I'm going to check power management IC, USB power management IC. This is our power management IC. I'm going to check all caps around. Looks that, there is nothing wrong with this console. At this point, I can say that I can't see anything wrong with it, but let's check this. So now I'm pretty sure that I won't make any short on the motherboard because I cannot see any. Let me just plug my USB-C meter and check. Looks, everything is perfect. Let me just flip over the plug. And if you got exactly the same behavior, yes, going to 0. For me, that means that the NAND memory is good. And the system also is good. So why my customer thought that is not going to work? I don't know. So what I'm going to do, I'm just going to put back my motherboard to the screen. And then need to check if you can see the picture on the screen. We should be able to put it up straight to the original firmware. Because, the chip is not installed. Alright, so I just need to plug the screen, that's it, and the battery. I don't need the speakers. Maybe, I plug the speakers because sometimes you can't see anything on the screen, but you can hear the sound. So it might be something else wrong, but we will see now. Alright, so I just plug one speaker. It should be alright. Alright, so like I said before, I'm not using this ribbon tape. I know that one resistor is missing, but I'm going to turn on the console by just plugging the charger. So let me have a look at it. Charger, and look, you see, we got a charging sign in the left corner. So I'm not sure if the, because the charging sign just disappeared. So I'm not sure if the battery is, charged enough to start the system, or maybe the battery is completely flat. So I'm going to unplug this, measure the voltages. We've got 4.1, which tells me the console is fully charged. So this is not good behavior. Just disconnect the battery once again. Remove that metal shield from here. Just wondering, what is this? Need to desolder this. Let's have a look under the microscope to make sure that there's no bridges between those two resistors here. I don't know what's there, but it doesn't look good. So they look nice. Here we got some mess. What's that, residue? It looks like a rust. You see, this looks like a signs of corrosion, actually. Was it liquid damage? I don't know. Alright, so one more try. Alright, so I've plugged the battery, and I'm going to... Alright, so now it should be able to turn on automatically. It's stuck. It won't go past through this step. The charging side is still on the screen, but we are not able to turn on the console. It is very, very weird. Is it because of that missing resistor, do you think? Honestly, I don't think so. But it looks like it won't... Oh, look what's going on with the screen. We've got some glitches. And it's glitched, I think, now. So I'm going just to take this out again and remove all these cables. Just quickly wipe this off. Go on the Microsoft and have a look at it closer. This job is not done properly. Hopefully its capacitor are not damaged on the APU. I just need to sort this resistor. It should be alright. So I'm going to quickly check in the circuit this resistor. So resistance mode. So the resistance of this is quite high, 0.5. 150 ohms. One is quite high, 0.5. And of course we've got different readings, so there's no way to measure this resistor without, desoldering it from the circuit. Alright, so here I've got that Nintendo Switch OLED motherboard, and what I'm going to do, I'm just going to remove that resistor from here, measure it out of the circuit. Because at the moment, we don't know the value. So how can I do it? I'm just going to heat up from the bottom, and I'm going to heat up from the bottom 400 degrees. And I'm going to try to not blow this out, because this is really, really tiny. I see. Let's cool down this. Alright, so fingers crossed that I won't lose this part. Come on. Show me the value of you. Something is wrong with my probes. Come on. Show me something. So I'm going to swap the probes on my multimeter. So one more try with my LCR meter. 18.6 million ohms. You see the results are 19.6 millions. About 20 millions ohm. Sometimes it was 18, 19. I think it's 20 million ohm resistor. So even my multimeter wasn't able, to read that value. Alright, but I'm going to solder, this particular resistor to the motherboard when this resistor is missing. So I'm going to go back to the microscope. Find the problem. Here's missing resistor. Let's apply some flux. And once again, I'm going to heat up from the bottom because I won't melt that, the connector. Alright, one of the difficult job to do was this one. Put back this tiny resistor. For me, this looks like it was the liquid damage actually. It was. You notice the area here around. Looks like the solder mask comes off. This looks like some kind of residue is already there. Know what? Alright, but we did it. We finally soldered that missing resistor. Let's check if I damaged something on the other side of the board, because I was heating up this board from the bottom, and this is the bottom, so everything looks normal. Alright, so what I'm going to do now is, I know that we've got a picture, but you can only see the charging sign. So my next step is to plug fully charged battery, and now I'm going to plug my USB-C meter and watch what's going on. Alright, so it's charging the battery, and now it should cut off this, yes, and now it's loading to the main system. So now we are in the system. It's booting up, I think, because the moment when, everything cuts off the power, it was the moment when this device turns on. Alright, so what I'm going to do now, I'm going just to unplug the charger first and the battery first, and now just need to make sure we can see the picture on the screen. So what do we need? We just need to connect this console to the screen and the battery, and now the console is ready to turn on. So let's confirm, because in my opinion, the console now should work perfectly fine. We will see now. Yeah, so we've got the charger. We should see the charging sign on the left corner, and now we should cut off, and now it should boot up the normal system, and we've got it. So I can disconnect this because the battery is charged enough. Screen brightness. Someone has put, some the normal tape, transparent. He put on the screen just to protect this. Right, so let's go to the system. The system is 14.1.2. At the moment I'm doing this video, the latest system firmware version is 16.0.0. But they released this system yesterday, and there are a lot of problems with this version of the system. Atmosphere is also 1.5, which can handle 16.0, but there are many problems that I would recommend to stay at this version of the system, and then when they improve atmosphere to the official 1.5 version, we can update the system version to the 16.0. But at the moment I would recommend to stay at this version of the system, because they need to do sign patches, etc, etc. So there's lots of things to do. It's better to leave this system like it is. Alright, so now we've got working console. Before was completely dead, so that means this tiny resistor was important, and this resistance of this resistor is according to my RCR meter about 20 million ohms. I don't know if this value is true or no, because I tried to measure it by my multimeter but I couldn't. So because my multimeter probably is out of range or something like this. I've tried to replace my probes to the different ones, but the different probes, of course, there's a product from China and they're very low quality, and it was showing me different numbers, so it wasn't so accurate. Alright, so now this is the moment that we can carry on with the job we need to do, yeah? So what my customer asked me to do, he asked me to fix this console first, and then when it's fixed, we can start to reinstall that chip he provided. So this chip is version 5.3, And my customer also asked me to install permanently point .0. So he wants me to remove this from here and reball the NAND memory and to solder permanently .0 cable, so he won't have any problem in the future with this point, because this point is a little bit dodgy with the different adapters. I've done many, many techniques. First, my job was, I was doing always permanently .0, but after that, they released the adapters. I was using the adapters. I was doing, the permanent job with adapters, but some of the chips, like, that SK, Hynix, this other brand of the eMMC chips, is very, very problematic. Alright, so I'm going to remove that adapter, I'm going to remove the chip, reball it, put the permanent point .0 and solder this back again. Alright, so let's go under the microscope now. We just need to remove this guy. Alright, so I'm going to add some flux. I'm going just to remove the NAND memory first. I will remove this adapter later. So first, what I'm going to use my hot air setup for 280 degrees, hwfly 80. So I just need to slowly, smoothly heat up that chip up to 350. Right, so now increasing the temperature to 330 degrees. And we can stop at this temperature, we will see. Alright, looks like 330 is alright. Maybe it takes a little bit longer. But just in case, I will increase this at 20 degrees, so it's gonna be 350. As we can see, my customer, he did actually, a good job with this point. Maybe it's not like in the same position like it was before. As you can see, it's not in the middle, but we've got chip off. Now we need to clean the area, remove the old solder, remove that NAND adapter. So I'm going to use the soldering wick, especially on these points. We need to get rid of this. My customer wanted permanently in the way I was doing this before they released adapters. It was only one method to do this. You had to remove that chip and solder the wire permanently. Now we've got different adapters, different techniques, easier, but it doesn't mean that it's better. Can't believe it. Look how strong is that connection at this point. Alright, so let's clean it. Let's apply some more flux. My low melt solder. And let's spread it gentle, without scratching the board. Alright, and now soldering wick. Don't press it too much, otherwise you will remove the solder mask from different points and you will have the problems later. It is done. So now next step is to solder the pad, because I'm going to use the pads. Alright, so we just need to solder this thing to the third pad. 1, 2, 3. We just need to solder this here. Can we do that? Alright, finally. Alright, so this job is done. So now we need to take our eMMC. Alright, so now we just need to do the same steps. Apply some flux. Let's melt fresh solder without the magnetic plate. Gently, just very gently spread. We need more. We just need the soldering wick, which is here. Just gentle. Let's clean this with the isopropyl alcohol. Alright, so we need to find that corner, and I can see this. Alright, let's apply some solder paste. Just a little bit. Alright, so hot air set up for 230 degrees. Going to put my tweezers here. Let's apply some isopropyl alcohol. All right, and we are done. Let's clean the chip. All right, so we just need to put back our chip in place. I'm going to apply some flux. Let's heat it up. 330 now. Just only the parts. Okay, now let's put the chip. Let's position the chip properly. So we've got small dot here and one dot is here. Just quickly check if I put this correctly. Yes. So let's position this chip properly. It should be like this. All right, so now I'm going to use my hot air to 300 degrees. Airflow like 40. Airflow 40. And let's gently heat it up. Oh, our chip is moving. All right, so now I'm increasing the temperature to 330. And still, I just need to still keep the airflow at 50. And as you can see, our chip is moving again. Let's apply some more flux and heat it up again. All right. So now I think the chip is soldered properly. I did a little bit a notch test, just gently. I don't want to break the connection between this cable and that 0 point. So when it's cooled down, I will clean it. I'm going to scratch a little bit this surface and measure the resistance. All right, so let's clean that flux. All right, so now it's clean. Let's scratch this tape here. And now I'm going to measure the diode mode. We should have 0.5 up to 0.8, 0.9. So black probe on the ground, red probe here. And I think this is very good. I think that we've got the connection. So the eMMC chip is soldered back properly, I think. So the first test before I put it back and connect the screen is to test with this USB meter. So we should have some readings and then it should go to 0. If it doesn't go to the 0, that means there's something wrong with my soldering job. Oh, 40 and 0. And let's flip over the plug like this. And perfect. Looks like everything is fine. You know, if you've done something wrong with the reballing, you won't have 0. It won't drop to 0. So if it won't drop to 0, that means there's a problem with the soldering job. Maybe there's a problem with the, you know, the files on the partitions. Maybe they are damaged, corrupted, whatsoever. But in this case, you know, the Samsung and eMMC, they are the best for me. We've got also Toshiba and we've got also SK Hynix. I don't know how to even spell it. All right, so let's quickly test it before I will carry on. So let's quickly test it, if you can see any picture on the screen, and then I will carry on with the mode. Now I'm going to plug my charger and it will automatically turn on this console. Yes, we've got charging sign and now it should turn on the yes. All right, so the job is done properly. So now I can carry on with the mod chip. Alright, so we need to go under the microscope and then carry on our job. So I'm very happy with the results. Very, very happy. So now let's solder jumper wires and then the rest of this. Let's add some flux. Alright, so it's soldered nicely. So I can just clean this off and put a shield on it. This is the old flux or maybe the corrosion. Missing part. Do we have the shield? Yes, we do have. So now I'm going to cut off the excess of the wire. Alright, so now let's try to solder point B, which is here. Here you just need to be very careful because near you've got 2 resistors. And I know the case is that, you know, people didn't notice that. So they just blow away this resistor, and without this resistor this chip won't work, and even without chip it won't work. This is very important, so be careful. Now that this point is big enough to, you know, avoid the problems, but like I said, so many people, they just unsoldered it by accident, then they don't know what's going on. Make sure the two resistors are still in there. So now I'm going to cut a little bit longer. All right, another step. This point is already soldered, but here we've got the problem. Why? This is the ground. This part, this huge, you know, surface is a ground connection. So this point, which is point D, is very close to the ground. We can by accident solder them too, and we will have the problem. So I need to solder this later. Gentle. All right, so let's take now our 3.3 volts. Let's solder this. All right, so our 3.3 volts wire is soldered. All right, so what left? So next step, I'm going to solder the ground point. All right, so now the point B, now the point D and point A. All right, so let's apply some flux and hopefully not connect to the ground point. I'm going to start from this. It's soldered. So now multimeter in the diode mode, black probe on the ground, and let's test it now. Now this is the proper value of this point. So here we've got 0, which is the ground. We need to secure this area with the soldering mask. Yeah, and this is correct. This is point D. All right, it's enough. So now I'm going to use my ultraviolet light. Let's check this. All right, so we've got point D. Now we just need to solder point A. All right, that's it. So the point A has been soldered and should be right. Now the last step, we need to reuse that thing. So we need to solder this ribbon tape back to the APU, and this is our last step actually. And then we can just connect each wire to the certain point on the chip. I always thin by, you know, the solder both sides of this ribbon tape, just in case. I should change my tip. And let's check the other side of the tape. This is really nice. So now it's time for our APU. Let's clean this. Right, first I'm going to solder those 2 points just to make it more stable. Alright, I should carry on my job, but I'm just wondering, you know, if this go to the beep mode, continuity mode. Now I'm going to measure. We should have from something like 9 ohms up to 18 ohms. Yeah, this is good. So that means this is connected. Yeah, this one is exactly the same. It's connected internally in this ribbon tape. So basically we just need to solder one of them and should be alright, but it's always better to solder 2 points. You can have you can make sure that, you know, one point is not soldered properly, another one it is. This doesn't look good. I think it's not connected at all. Alright, now it looks much better, more solid. Okay, so let's check now. 15 ohms, 0 ohms, 15 ohms, 0 ohms. Alright, that's fine. This is the most important for me. Okay, so my next step is to prepare the APU shield, clean all thermal paste, to peel this off and what for the... Alright, so now I just need to cut off this, because we don't want this shield to touch our points, especially point D. Alright, so now it's okay. Put some double-side tape, just like this. Just like this. Cut this off. Right, so let's apply the thermal paste. Alright, should be alright. Alright, here's our chip. So I'm going to put that tape in first, because I can see that some flux is on there. Alright, so this is the place for our chip. What I'm going to do, I'm just going to peel this off. It's our protective film. And we just need to solder certain points to the certain pins on the chip. Let's do this. Let's go under the microscope. Let's quickly finish this job. Right, point B is soldered. Alright, so point D, this is the one that I told you about. The two resistors are very close to it. Need to be careful. So the point B is soldered. So now we need to find the ground. Because you know, this is the new chip. Some old version, the ground in this place. It's now the beginning is the ground point. At the end, we've got 3.3 volts. So our ground point is here. Goes from here. Alright, so first ground point. Right, so our ground point is sorted. So now we need to find point D, which is here, goes from here, here. Point A, which goes from here to here. Alright, so the job is done. We just need to quickly clean these points, measure, and when everything is good, we can connect it to the battery and plug the charger. Set up the multimeter on the diode mode. So we are in the diode mode right now. Let's check the values here. So the black probe on the ground and ground 0, 0, yes. D point is okay. Aim point is okay. C point is also good. And 3.3 volts is perfect. So now point B left, we should have here 1.2, 1.8 or over the limit. And we've got over the limit. Everything depends on the chip you've got. So now I'm going to put this thing, I'm going to assemble a little bit our console. So don't forget this charging port. So now I'm going to remove that fan. Alright, it is in all place. So we just need to quickly connect everything back together. Then measure gain the same points, just to avoid some shorts. The last step is to power this on. So the OLED screen is connected, speakers. One more thing, probably right slider. And as I said before, let's zoom in and measure those points again. No. Maybe you know what I should do. Put some screws back in. Alright, so let's measure it back again. Black probe on the ground. We should have ground 0, 0. D point good. Perfect. Super. Also nice. Alright. So everything looks fine. Let me just put the fan back again. A moment of truth. Let's press the power button. Alright, so you know, from the messages my customers send me. Alright, so this is the message from my customer. I've marked the missing resistor in red. So it was that resistor what we replaced. And since the hwfly version 5 is stuck in training mode, bricked red, green, yellow, flicker, red, green. Yeah, so we've got exactly the same situation. So what I'm going to do, I'm going just to disconnect the battery. I know it's the problem with the chip. So we need to fix that. I'm going to use my tweezers. See those 2 points here? They are to reset the console. So we just need to put our tweezers here, plug the battery, and press the button. And you see? And now release tweezers. So now I'm going to turn this off, or just unplug the battery. And let's try again. Something is wrong with this chip. I think something got burned on the chip. Alright, update. I'm going to update the firmware on the chip now, right now. So as you can see, this we've got up here. That means this is the top. You need to plug this like this. If you do it on the other way, you will burn the chip. Alright, so now we are in the program mode. So now I'm going to program this chip. Alright, so now I'm going to use this the latest edition 0.72. Alright, now we can disconnect our cable. I'm going just to plug the battery and try one more time. Alright, so now I can see that it helped. The fresh version of the firmware helped. So what I'm going to do, I'm just going to disconnect this just in case. Alright, so now I'm connecting, you know, the SD card. And we've got Hecate. Alright, let me just quickly check if we can go here. Alright, so the problem is with the SD card format. This is my card actually, because you know I couldn't see, because I always ask to send me you know the switch, the chip and the SD card, but in this case I couldn't see any SD card in the parcel, so I'm not able to start this console with the SD card in exFAT format system. It should be FAT32, because you know the console arrived broken. I couldn't even put SD card, update it. But you know, as I said before, the version of the system is probably 14.1, something like this. And now at the moment I'm making this video, yesterday or maybe 2 days ago they released the version of the firmware 16. And the problem is that there are so many problems with Atmosphere and version 16 that I just prefer to wait until the release Atmosphere 1.5, not the pre-released version, just normal version. So my customer will have to update the firmware later. So now how we can test this? We just need to find the SD card which is in FAT32 system. I'm not sure if I've got the card in FAT32, but probably I've got one card, 32 gigs. You can see this is very old one, but can we vote it to the custom firmware or no? It's very interesting. Blue screen, all dead. Something is bricked. Software? I don't think so. The firmware? I don't think so. Maybe my SD card is no good. What I'm going to do now, I'm going to reformat my SD card. Okay, so I've already prepared the SD card. Hopefully this will work. So my SD card with my files, it was the problem. Alright, so now we are in the main system. We've got version of the system 4.1.2, Atmosphere is 1.4.0. Like I said, you've got Atmosphere pre-released version 1.5, but I wouldn't try this, because I don't like to do some new experiments, so I just prefer to wait when they release the official version of Atmosphere, and then I will try to do something. Yeah, but at the moment it's okay. As we can see, everything is working fine. It's no problem at all. It boots up very, very fast. It's got the Samsung NAND memory, which is the best one. And what I can say more? Nothing. So, my customer sent me this console to make a backup and to fix what he's done. But probably, because I can't see anywhere has his SD card, but probably I won't make a backup because he didn't provide the SD card. So, he needs to do this by himself. It's easy. I've done it many times. I can explain him, send him a guide how to do this. I hope you enjoyed this video. Please like and subscribe. And see you next time!